Hi everyone, this is Aruna, Assistant Professor, Department of Information Technology, SNS College of Technology. In my lecture series today, we're going to see about what do you mean by memory location and addresses in computer architecture. So memory location, how we can determine the memory or computer memory. It is an organized component so that user can effectively store and retrieve the information from the computer. For that purpose only, we are using a computer. Your memory consists of the millions of storage cells. So that could be a flip-flop. So each cell can capable of storing one bit of information at the same time. So this is the logic circuit of a flip-flop. This is the how a memory cell can be looked. Second thing is, what do you mean by memory location? So each group of n bit is referred to as a word of information. That n can be called it as a word length. Word length can be varied from 8 to 64 bits. Unit of 8 bits, we can call it as a byte. And unit of 4 bits, we can call it as a nipple. A 2 nipple, we can call it as a byte. For accessing the memory to store or retrieve the single item of information that can be calculated in terms of words and bytes. It requires distinct address of each item location. So that particular occasion can be referred from 0 to 2 to the power of k minus 1. As the address of successive location, we are using only a contiguous location, or we can call it as a successive location in a memory system. And also, if 2 to the power of k is my addressable location, means then 2 to the power of k address constitute the address space of my computer. For example, a 24-bit address generate the address spaces 2 to the power of 24. So totally my memory capacity is 16 MB. If it is a 32-bit address, it will create address spaces 2 to the power of 32. That is 4 gigabyte. That is a 4 GB location. This is the how a memory location can be calculated. Here, when compared to the memory, we are going to see about the byte addressability, or we can call it as an assignments. A byte is always 8-bit, but word length typically ranges from 16 to 64 bits. In byte addressable memory, successive address refer to the successive byte location in a memory. Your byte location can be addressed from 0, 1, 2 up to n. If word length is 32-bit, the successive words are at the addresses from 0, 4, 8, and each word can having the 4 bytes. So this is the how a data can be stored. This is the first word, second word, and third word. So always we are transmitting from least significant bit to most significant bit, or we can write a data in our memory from most significant bit to least significant bit. So this only we can call it as a little Indian and big Indian. That we will see it in my next part. So here, this is the how we are storing our data from LSB to MSB. Your MSB bit, last bit, we can call it as a sign bit. If it is a 0, that is positive. If it is 1, that is a negative. So here in our character, we can split it into 8-bit, 8-bit, 8-bit. So it can be converted into the ASCII character. So this is the ASCII value of the numbers. So your big Indian and little Indian, these both are the assignment in byte addressability. Your big Indian is used to when lower byte address to we are writing a word from LSB to MSB. That is a big Indian. Sorry, MSB MSB to LSB, that case called as a big Indian. Little Indian is LSB to MSB. So only we can call it as a lower byte address or used for the least significant bit. Here lower byte address can be used as a most significant bit. So this is the how was a better example for the little Indian, big Indian. The way of people is always broken. The X is the little put land. That can be called it as a big Indian. So the way of king then order the people to break their egg. So that is a little Indian. See here, in little Indian, your data can be written from least to most. Here, your data can be written from most to least. This is the basic difference between the little Indian and big Indian. So only I gave you the example. The real-time application where we are using this concept means in Intel processor, Pentium processor, 80386 architecture and processor and all, we are using a little Indian. Motorola 68000, 68030. In that type of processor and all, we are using a big Indian concept. So this is the how a how the byte address can be stored in our memory. So that's all about our memory addresses and the memory thing. The next my video we're going to see about the memory operation. Thank you for watching my video.